So this is section 6.5, and we've already started developing the basic definitions from trig, and we've talked about converting from degrees to radians and back and forth, and we just defined the trig ratios in the last section. So we're going to start to develop something here called the unit circle. So first of all, let's look at the big picture in degrees. So we know that if we start over here on the positive side of the x-axis, we're at 0 degrees, and we talked about how each quadrant is 90, so the top is going to be 90 over to 180 down to 270, and then if we come all the way around, we're back at 360. If you look at this line that's right here in the middle, right there in the middle of the quadrant, it makes sense that that would be a 45, since 45 would be in the middle of 0 and 90. And so if we wanted to, that means this line over here is going to be halfway between, okay, that's a terrible line. This line over here is going to also be halfway into the quadrant. So that's going to definitely be 135. Make that decent. Okay, there we go. So that's going to be 135. And I could continue to do that. So all of these lines are the kind of halfway into the quadrant, the 45 lines. So that, if I just keep adding on 45, that means this one down here is going to be 225. And this one over here would be 315. Okay. Notice this first line is a third of that first quadrant. So this one would be the 30. And if you'll notice, this is 30, this is 30, this is 30. Hopefully that makes sense. Those are your 3 30s. So that means these other lines are going to be 60. So if we're up here to 90, then another 30 would be 120. And then if I go another 30, we're at 150. And then after the 180, if I come down 30, we're at 210. And another 30 would be 240. Okay, then we get to the 270. So if I go another 30, I'm going to be at 300. And then another 30, we're going to put over here at 330. Okay, so that's, if I kind of mark off those numbers in degrees all the way around. So let's talk about what that would look like if we do that in radians. Okay, so we know that 0 degrees is the same as 0 radians. And 90 we know is pi over 2, because pi is actually 180. And if I go another half, so we're down here at 3 pi over 2, and then back all the way around would take us to 2 pi. Okay, but let's talk about these middle lines. So if this is my halfway, right, that's my 45, and you may remember that when we were converting back and forth, we said that we know that 180 divided by 4 is 45. So that's why this we're going to call pi over 4. So this is your pi over 4, or your 45. This is 45. This is 45, and this is 45. Maybe I should do it in different colors so you can see it. So you've got, this is a fourth, this is a fourth, this is a fourth, and this is a fourth. And so hopefully it makes sense that that 45 is pi over 4, because it takes 4 of them to get all the way over to pi. So if I want to finish labeling all of those middle lines, just count up how many fourths it was. So this is my 1/4, 2/4, and then in order to get over to this line, right, I'm going to be 3/4. Whoops, sorry about that. I'm going to be at 3/4, and then down here all the way to pi would be 4/4. So if I want to write those over here, this is going to be 3/4 of pi. So I could think the same concept down here. This is a fourth, and another fourth. So this one is going to be a fourth more than 1, so 5/4. And then if I go another fourth over here, this one's going to be 7/4 of pi. Okay, so now let's talk about these 30-degree lines. So this one was 30, and we know that pi over 6 is 30 degrees, right? Because 180 over 6. So that means each of these is 30-degree marks is going to be another sixth. So if I go up to here, it's going to be 2/6, which would be 1/3. So pi over 3. Whoops, sorry. So up to get to 1/2, it makes sense that that would be 3/6. So if I go another one, 4/6 would be 2/3, and 5/6. And then 6/6 is where we get to 1 pi. So then 1 and 1/6 would be 7/6. If I go another one, that's going to be 8/6, which reduces to be 4/3. So let's see, this would be 9/6. So 10/6, which reduces to be 5/3. Then 11/6. Okay, so those are all of those kind of middle lines. And these are the common numbers. These are the ones, the reason we only label these is because these are the ones that come up all the time. The 30 degrees reference angles, the 60-degree reference angles, and the 45-degree reference angles. Okay, so let's kind of put this together in a big chart. Okay, so we're just going to think about one full rotation, right? The full 360 degrees. So let's skip down here to this chart. We're going to be back and forth in these two pages. So first of all, let's change all of the degrees into radians. And you could look at the picture up above, but we don't really need that. So I know 0 degrees is 0 radians. We said that 30 degrees is pi over 6. We said 45 is pi over 4. We said 60 was pi over 3. 90 was pi over 2. And then if you start coming back down the other side, again, you could look at that picture that we set up over there, but you could look at this and say 120 is actually 2 60s, so that's why it's 2 pi over 3. 135, we said, is 3 of the 45s. 150 is 5 of the 30s. And then 180 is pi. So we're just writing the radian measure for each of these all the way down. So remember 210, that's like 7/30s. And 225 is 5 of the 45s. 240 is 4 of the 60s. We know 270 takes us down to the bottom, 3 pi over 2. 300 would be 5 of the 60s, 7 of the 45s, 11 of the 30s, and then back to 2 pi. And it might be helpful if we kind of divide up these quadrants. So like, let's draw a line right here, 0 to 90. And then I'll show that our first quadrant is right above that. I can scooch that up a little bit. Well, good enough. So this is the first quadrant. And then under the 180, we can draw the second quadrant. And then under the 270, we can draw the third quadrant, just to kind of help us identify. So now let's go in and let's talk about the reference angle. So a reference angle, remember, is from the terminal side to the closest x-axis. So the first quadrant ones are all going to be exactly what the angle measure is. And we could either write it in degrees or we could write it in radians. So then 120 is actually going to be 60 from 180, 45, this is 30 from the 180, and 0. And do you notice that in the first quadrant we went up 0, 35, 45, 60, 90, and now we're headed back down towards 0 again, right? 60, because we're headed back towards that other side of the x-axis. And so now in the third quadrant we're headed away from the x-axis, so we're working our way back up. So 30, 45, 60, and 90. And then we're working our way back down to the positive side of the x-axis. So this is going to be 60, 45, 30, and back to a 0 degree reference angle. Okay. So now we want to fill in the trig functions for all of these angles. Okay, so let's start up here. Just to kind of show you how this chart works. So say, for example, let's say I'm looking at this box right here. Okay, in this box, we're going to figure out what the tangent, because we're looking up here, excuse me, of 45 is. So this box would be filled in. We're finding out what the tangent of 45 is. Now, I don't want you to write that in there. I just want you to know this is how we would look it up. So this is going to be kind of our big chart. If I want to know any of the trig functions of any of these special angles, this is going to be the chart that we're going to go to. Okay, so in order to do this, let's draw some pictures. Let's start with a 30-degree angle. So if I were to sketch the 30-degree reference angle, there's my initial side, there's my terminal side. I know that this is my 30-degree angle. And if we were to turn that into the reference triangle, right, drop that perpendicular line, then look at this triangle. This is actually going to be a 30, 60, 90 triangle. And you may remember from geometry, if you have a 30, 60, 90 triangle, then you know that the ratio of the sides is 1 to the square root of 3 to 2. So if I label these sides, so opposite the 30-degree angle, I'm going to give that a measure of 1. Opposite the 60 is going to be a measure of square root of 3. Opposite the 90 is going to be a measure of 2. Now, when we were labeling these reference triangles the other day, remember the one down here at the bottom is the x, because that's on the x-axis. The vertical side was the y, and then the hypotenuse was the r. We called it the radius vector, so we call that r. So I can look at this triangle, and remember the 30-degree, that's our theta. So I could look at this triangle and I could say, all right, the sine of 30 is, and if you think about our definitions from the other day, we said the sine is y over r. So in this case, it's going to be 1 over 2. I could look at the same triangle and I could say, well, what about the cosine of 30? Well, the cosine is x over r. So that would be square root of 3 over 2. And I could say the tangent of 30 is y over x, so that would be 1 over square root of 3. So there are 3 values that I can fill into the chart. So we said the sine of 30 was 1/2. The cosine of 30 was square root of 3 over 2. And then the tangent of 30 we said was 1 over square root of 3. Okay, so we're going to skip around and filling this in. Let's go back up to our picture and look at number 2. It says, what if you have a 150? Okay, so if I'm going to go to 150, that's going to take me over here into the second quadrant. Okay, that's my 150. If I form that into the reference triangle, So the reference angle inside this triangle right here is a 30. Okay, that's our theta, which means even though the angle was 150, doesn't it still represent a 30, 60, 90 triangle? And so if I label those sides, opposite the 30 is 1, opposite the 60 is always square root of 3, and opposite the 90 is 2. But this time, the vertical side is 1, so the vertical side is, remember, always your y. And this x-axis down here is my x. Hypotenuse over here is always my r. So even though it's a 30-degree reference angle, the actual theta that we're talking about is 150. So I could say the sine of 150, because it's still represented by this 30, 60, 90 triangle, I can use my y over r and say 1 over 2. And the cosine of 150 is x over r. Which, yes, is the square root of 3 over 2, but notice if I'm in the second quadrant, isn't the x value going to be negative? So the x is actually a negative square root of 3. And then the tangent of 150 is going to be y over x. So that's going to be 1 over negative square root of 3. So let's fill those in. So the sine of 150 is 1/2. Cosine of 150 was square root of 3 over 2, and I think we said negative. And the tangent is going to be 1 over negative square root of 3. Okay. Not that we need to go through and draw all of these, but notice that the 30-degree line has the same numbers as the 150-degree line. Why? Because the reference angle is the same. So remember, it's all about the reference angle. So that means all of these that have a 30-degree reference angle, all of these that have a 30-degree reference angle are going to have those exact same values. So I can fill in the 210 down here as a 1/2. Square root of 3 over 2. You know what? Let me keep all this in a consistent color. I think I'll put them in black. So 1/2 square root of 3 over 2 and 1 over square root of 3. We'll talk about the negatives in just a minute. And then the 30 down here, the 330 is going to be 1/2 square root of 3 over 2 and 1 over square root of 3. Now we're going to fill in more in a minute, but let's think about positives and negatives, because notice in the second quadrant we said these values are going to be negative. So let's think about this. In the first quadrant, both the x and the y are positive, right? Any ordered pair with x and y are positive. In the second quadrant, the x is going to be negative and the y is going to be positive. In the third quadrant, both x and y are negative. And in the fourth quadrant, the x is positive, but the y is negative. So why is that significant? Because remember our trig ratios, the sine is y over r, cosine is x over r, tangent is y over x. So that means that the sine function depends on y as far as being positive or negative, because remember r is always positive, and the cosine function depends on x, whereas the tangent, it depends on both of them. So in the first quadrant, since both x and y are positive, that means all of the trig function values are going to be positive. But in the second quadrant, since the x is negative, that means that cosine is going to always be negative in this quadrant. And since the tangent is y over x, positive over negative, that means the tangent is going to be negative in this quadrant. Okay, what about in the third quadrant? Well, since y is negative, that means the sine is negative. Since x is negative, that means the cosine is negative. But since tangent is y over x, that would be negative over negative, which means the tangent's going to stay positive. And in the fourth quadrant, since the y is negative, that means the sine is going to be negative. But the x is positive, so the cosines are going to be positive. And then the tangents are going to be negative over positive, so all of the tangent values are going to end up negative. So determining whether the value is positive or negative all depends on the quadrant. Okay, so let's go to a 60-degree angle. So look at number 3. If I have a 60-degree angle, so right here, and if I turn that, so that's my 60, if I turn that into a right triangle, even though the orientation is different, isn't it still a 30, 60, 90? So opposite the 30 is 1, opposite the 60 is square root of 3, opposite the 90 is 2. So there's my x, y, and r. So remember, our theta is 60, so we could say the sine of 60, y over r, is going to be square root of 3 over 2. Cosine of 60, x over r, is going to be 1/2. And then the tangent of 60, y over x, is going to be the square root of 3 over 1. So just square root of 3. Okay, so let's fill those in. Sine of 60, we said, was square root of 3 over 2. Cosine was 1/2, and tangent was square root of 3. Well, can't we do a similar thing to what we did earlier? So doesn't that mean all of the 60-degree reference angles are going to have those same values? So down here at 120, that's a 60-degree reference angle, so that's going to be square root of 3 over 2, 1/2, and square root of 3. And we already have the negatives in there, so we don't have to worry about that. In the third quadrant, that 60 is a 240, so that's going to be square root of 3 over 2, 1/2, and square root of 3. And in the fourth quadrant, we have a 60-degree, so square root of 3 over 2, 1/2, and square root of 3. So it seemed like this is such a huge, kind of daunting chart, but as soon as you know one of the quadrants, then you know all of the quadrants as far as the numeric values. Okay, so we've done the 30-degree reference angles, we've done the 60-degree reference angles. Let's go to the 45-degree reference angles. So look at number 4. So here's my 45-degree reference angle. And so if you think about that triangle, it's a 45, 45, 90. You may or may not remember from geometry, the ratio of the sides of a 45, 45, 90 is 1 to 1 to the square root of 2. So opposite each of the 45s is 1, and then the hypotenuse is going to be square root of 2. So x is 1, y is 1, and r is square root of 2. So the sine of 45, y over r, is 1 over square root of 2. Cosine of 45, 1 over square root of 2. And the tangent of 45 is going to be 1. Now, something I do want to mention is that we don't normally care that much about rationalizing, but the one that is generally always rationalized is this 1 over square root of 2. I don't know why this one and not others. So if we rationalize, multiply the top and the bottom by square root of 2, we're going to think of this as square root of 2 over 2. All right, so let's fill that into our chart. So the 45, square root of 2 over 2, and both the sine and cosine were the same, and then the tangent was 1. So all of the 45-degree reference angles are going to have those same values, right? All of the 45-degree reference angles can have the same values. And the last one down here. Okay, so we are really starting to get this filled in. So let's think about a 0-degree angle. All right, so if I have a 0-degree angle, I've got my initial side, and then my terminal side is laying right on top of that. So you can't really see the triangle. So let's kind of fudge a little bit here. So let's pretend like this is 0 degrees. I know it's actually more. I mean, it might be 5 degrees, but let's just pretend like it's 0. I just raised it a little bit so that I could actually see if there was a triangle, I could see what it would be. Okay, so keep in mind, this really is 0. We just raised it so that we could picture it. Okay, so I can't really say this is a special triangle. It's not like it's a 0, 90, 90 or something like that. So let's think about this way. I know that this side down here is the x, and I know that this side over here would be the y, and that the hypotenuse would be the r. Okay, now if this really were a 0 degree angle, then I wouldn't have that y value, right? Because the r would be right on top of the x. So really the y would be 0 if it were really a 0 degree angle. Okay, so you're like, well, but I don't know what x and r is. Okay, well, let's think out loud though. The trig function for sine of 0 degrees, if it's y over r, it's going to be 0 over r. So 0 over anything is 0. So it doesn't really matter what r is in that case. And the cosine of 0 is going to be x over r. But think about this. If in this triangle, if the y is 0, if the r is on top of the x, aren't x and r the exact same thing? And if they're the exact same thing, wouldn't this equal 1? And then the tangent of 0 would be y over x. So 0 over x, which is still 0. So even though we couldn't really see the triangle and we kind of faked it a little bit, I can still find the values based on the ratios. Okay, so the 0 degrees is 0. The cosine of 0 is 1. The tangent of 0 is 0. And so now I can fill in all of the 0 degree reference angles. So here's a 0 right here. And you may be saying, how can you have a negative 0? Well, it doesn't really matter if you write negative or positive, right? I mean, 0 is just 0. So I'll erase the negative, but it didn't matter. And then there's another 0 degree down here on the 360. So 0, 1, 0. And again, if it's a 0, I don't really need to say it's positive or negative. Okay. So the only one I have left is the 90. And we're going to kind of think of this similar to how we did the 0. If I have a 90, my initial side is down here. My terminal side is up here. But since I always, to form my right triangle, I always go from that point straight down. So I don't really have a triangle. A lot of people want to like draw this in here and say, oh, there's my right triangle. But that's not how we form reference triangles. We never have gone from the end of the terminal to the end of the initial. We've always gone from the end of the terminal straight down. Okay, so let's kind of, fake it a little bit for just a second. Let's pretend like the initial side went to right here. So I know really that's probably like, only 85 degrees or something, but let's just pretend like it's there. We'll pretend like it's all the way up at 90 so that we can see if I were to drop that line straight down so that I could form my right triangle. Okay, even though it's really only 85, we're calling that theta 90. So think about it. If that were a 90, then really wouldn't this y side be on top of the r side? And it would be the x that doesn't really exist, right? Because if I could take this line, whoops, sorry. Well, if I can identify it, if I could take that line and scooch it up, then the y would be on top of the r. Okay, so in this case, I would say the sine of 90 is y over r, but y and r are going to be the same thing. And the cosine of 90 is going to be x over r, so 0 over r. And the tangent of 90 is going to be y over x, so whatever y is, over 0, well, anything over 0 is undefined. Okay, so for 90 degrees, the sine is 1, the cosine is 0, and the tangent is undefined. So let's fill in all of the 90-degree reference angles. 1, 0, undefined. I think that's it. Okay. So if I want to fill in these other two or other three columns, it's going to be easy to do. I don't need to redraw all of the triangles because I can just use the concept of reciprocal. So just let's look at this one right here. Here is my sine column. Isn't the cosecant the reciprocal of sine? Isn't the cosecant r over y? So couldn't I just take each of those values and flip it over? So the reciprocal of 0 is undefined. The reciprocal of 1/2 is 2. The reciprocal of this square root of 2 over 2. It's okay if you want to write 2 over square root of 2, but remember that first came from 1 over square root of 2. So it might be nicer to say that the reciprocal is square root of 2 over 1. And this one would be 2 over square root of 3. The reciprocal of 1, if you flip it over, is still going to be 1. So if I want to go to, let's say, the secant, well, isn't the secant the reciprocal of cosine? So I could take the cosine column and flip it over. So the reciprocal of 1 is 1, 2 over square root of 3. Again, we're thinking of square root of 2 over 2 as being 1 over square root of 2. So the reciprocal is square root of 2, reciprocal of 1/2, and we said the reciprocal of 0 is undefined. So you could follow that same pattern and fill in all of those last three columns by using the idea of reciprocal. Okay.